Hi everyone, welcome to Rakesh sir lecture. Today we are going to discuss about neural limit of visual acuity. It is the continuous lecture of visual acuity on visual acuity. So in this we are going to see about, because of the neural density, neural cell density, that means retinal cell density in this retina, how this our vision is limited. Okay, so for this let us explain. So this is eye. Okay, so in this this is the optic axis. Okay, this is the optic axis of the eye, and as you are seeing, this is the what image? Retinal plane. Okay, this is the retinal plane, and in this we are going to place an object. The same examples. Okay, if you have not seen that video, please I request you to go back, watch that video at least up to the 5 to 10 minutes of that video, like how I have explained about how I am keeping the object. So I'm going to keep the letter E. Letter I'm going to place just letter E. Okay, this is letter E and this. So I'm just going to place this two part, because in earlier lectures I have explained, if these two lines can be resolved, that means automatically this up and lower limb also can be resolved, right? Because this middle and lower limb is forming a smaller angle. So if a smaller angle are getting resolved, that means this upper and lower, they are forming larger angle, obviously they should get resolved, right? So I'm going to make now this two line in magnified view, right? So let me draw this in magnified view. So this I am making in a magnified view. Okay, so but remember there is one more line, upper limb here. Okay, so this is middle and lower. So now, as I told, this is the optic axis. This is the optic axis on which just below this we have nodal point. Okay, we have nodal point, and this, after refraction through this, the light has to pass through the nodal point. The refraction is occurring here, so this light has to pass through nodal point, and one light is pass eyes here. So this will be, if this is A B, this object is, if A B, that means the image formed by this will be A dash and B dash, and this is the height of the image. Okay, and the angle formed by this will be theta, and as you know, that if the two lines cross each other, this also will become theta. Let's assume this C A dash D is an eye, right? And we are going to see about this is the retinal cells I have made in enlarged view. Okay, so just see, this line is striking at this cone cell of the retina, and this A is striking at this, and there should be one gap. So there should be minimum one cell gap between these two cells. So whatever we are going to see, this is, there is minimum one cell gap. That means whatever theta will get, that is the minimum theta, that is minimum angle of resolution. Why there is one cell gap? Have you thought why there is one cell gap? This is nothing but this, the gap, the light is coming from this gap, should go and strike here, right? Because if you keep like this and this, and there is no gap, there is no cell gap, that means they'll perceive two marker as one. So there should be gap. That means light entering from this gap, light is passing through this gap also, right? So this gap should strike this part of the cell. Have you am I clear up to here? So this whatever you have discussed till now, same things you have to write in the form of word. After this, we should know few parameters. like let this is cone cell, so the diameter of the cone cell is 1.5 micrometer. It varies, but okay, at least at the fovea region the diameter is how much? 1.5 micrometer. So I need to get this theta. I have to find this theta. This visual angle is equal to this one, vertically opposite angle. If two lines cross each other, the opposite angles are equal. So if I want to find this theta, I have to find this height and this. Are you getting this? So this theta equal to opposite by base. Opposite by base. Tan theta equal to opposite by base. So what is this distance here? So distance is this distance from here to here, it is approximately 17 mm. From nodal point to retina, this is approximately 17 mm. Okay, and I need to find out this. So what is this distance, height? This is half of the diameter of one cell, then the gap between the cell, again the total cell diameter, then again gap between the cell, then again half of the diameter. Okay, so just first write whatever I spoke, same thing I will write and calculate this height. So as I told, this the diameter, total diameter of the cell is 1.5 micrometer, and the gap between the cell is 0.5 micrometer. Okay, 0.5 micrometer. So let me calculate this height first. Retinal image height. So from the diameter of the half diameter of cone cell is equal to 0.75 micrometer. That means this is half. Total diameter is 1.5 micrometer. That means the light is striking, we are assuming, at the center of the cell. So if the center of the cell light is striking, that means 1.5, this half, it will be half. So 1.5 half is 0.75 micrometer. Now there is a gap. This is the gap between the cell. So as I told, the gap between the cell is 0.5 micrometer. The gap between cone cell is 0.5 micrometer. Have you imagined this cell, how much it is? It is just, if you take this hair, our hair, even I have less hair, if you pick this hair, the thickness of the hair is 20 micron. So even it is more thinner than the hair. The cell is more thinner than the hair. Okay, now we will continue over this. So we have continued here. Now we have one cell total diameter. This is one cell total diameter. So the diameter of the cell, is 1.5 micrometer. Okay, now again the gap between the cell, this one. So the gap between the cell is 0.5. The gap between cone cell at fovea is 0.5 micrometer. Okay, now what is left out here? Half of this cell, right? Half diameter of the cell. So half diameter, how much I told? The total is 1.5 micrometer. So half will be 0.75 micrometer. So the half diameter of the cell is how much? 0.75 micrometer. That means it will become total, if you calculate it, 0.75, 1.5, 1.5, and 3.54. So total is 4 micrometer. 4 micro. So minimum height should be 4 micrometer. Okay, so 4 micrometer can be written as 4 into 10 to the power minus 6 meter. 4 into 10 to the power minus 6 meter. And so now I can apply the formula tan theta. If I want to find out theta, so tan theta equal to opposite by base. So opposite tan theta. Now just erase this optic nerve as of now. So tan theta equal to, what will be the tan theta? Opposite by base. Opposite is a dash b dash. A dash B dash by base is N A dash or A dash N. A dash N. Okay. So A dash B dash is 4 micrometer. Okay. So just keep seeing here 4 into 10 to power. It's very easy actually. As compared to earlier lectures, neural limit is very, very easy and it will just complete it within a minute. I mean, within 5 minutes it will get complete. So, okay. 4 into 10 to power minus 6, right, meter. And A dash N is 17 mm. So 17 mm, if I want to write in a meter, 17 into 10 to power minus 3 meter. Okay. So you do a calculation 4 by 70, 4 by 17 and 10 to power minus 6, and here is 10 to power minus 3. So if you get this 10 to power minus 3, if you make it up, then this 10 to power minus 3 will be plus 3, and this 10 to power minus 6 plus 3, it will become minus 3, 10 to power minus 3. So 4 by 17 into 10 to power minus 3, this is in radian, because the value are very smaller, the angles are very small. 4 by 17 how much? Again we'll take the help of our calculator, right? So along with me, at least you people can calculate now. So 4 by 17, it is 0.235. So 0.235. So 0.235 into 10 to power minus 3. This is in radian. Okay, let me convert into degree. So degree, if I want to convert it, 0.235 into 180 by pi, because already I have discussed in the earlier lectures. So if you want to convert from radian to degree, we have to do by 180 by pi. So pi value is how much? 3.14, and into this 10 to power minus 3. Okay, so this is now a degree. So now do this again. We'll take the help of our supporter calculator. So this calculator, 0.235 into 180 into, not into, but 42.3 by 3.14, it is 13.47. This 13.47. 13.47 into 10 to power minus 3. This is degree. This is degree. If I want to remove this decimal, then what will be here? 0.03 times this decimal should move backward, left side. So 1, 2 and 1 0 I can put 0.013 degree. As this degree is very less, very small, very smaller, then we can write this is 10 theta, right? This is equal to 10 theta. So if we know, if the angle is very small, if the theta is very small, 10 theta is equal to theta. Okay, so 10 theta will be equal to theta. The same I can write like 10, this theta is equal to 0. As 10 theta equal to theta, as 10 theta is equal to theta, I can write this theta is equal to 0.013. This theta is equal to 0.013. Now this is in degree. I have to convert in minute of arc. So this theta now is equal to 0.013 into 60, because if you multiply by 60, you will get in minute. So now this value is in minute of arc. Now see here. Now what we can do is, again we'll take the help of our calculator. 0.013 into 60, 0.78. So 0.78 minute of arc. 0.7 minute of arc. That means your minimum angle of resolution should be 0.7 minute of arc. So approximately this MAR, this is MAR should be how much? 0.8 approximately. This is 0.8 minute of arc, which resembles with the optical limit, resembles with optical limits. So that means your neural capacity, based on this cell density, Based on this cell density and the diameter of the cells and the gapping up between the cells, you have capability to see up to like your MIR should be 0.8 meter of arc, because and vision, you have capability to see up to visual acuity equal to 1 by 0.8. In decimal it is 1.25, right? And if you want to write in 6 by 6 format, I can just multiply 6 by 6 and you will get 6 by 4.8. So you have capability to see up to 6 by 4.8, that is approximately 6 by 5. So your neural capability to see up to 6 by 5. So that's the reason even the pupil size is increasing. You know, in earlier classes we have seen, if you increase the pupil size, your vision will increase. Your vision will increase. But that is theoretically. But but the arrangement of the cell in our retina in such a way that it cannot take better. It cannot become, vision will not become better than 6 by 5. Right? Vision cannot become better than 6 by 5 or 6 by 4 half. It will not become until the cell will become more thinner. Until the cell will become more thinner and the gapping will decrease more, because in eagle eye, which has a surface vision, their gapping is not 0.5, their gapping is 0.2. So the gapping should increase, right? And their diameter should decrease. Then only you can have more amount of resolutions and have sharp visions and good visual acuity, right? But anyway, we have blessed with 0.8 minute of arc as a minimum angle of resolutions and a visual acuity 6 by 4.5 or 6 by 5, based on our recent or now arrangement of cells in the retina, right? So this completes our neural limit of visions. So why we are able to see up to 6 by 5, not better than that, because of the arrangement of the retinal cells, right? Because of the arrangement of the retinal cells. So unless we developed our anatomy and physiology of the eye further, or the cells density further, our vision will remain the same up to here. Okay, so if you want to increase our vision as a human species, something we have to do with the cell density here, and the diameter of the cells, it should become more thinner, and the gap between the cells, it should become more less, right? And then we can have a good and sharp vision like eagle. Hope the evolution will continue further and it will get achieve that, right? So okay, this completes our neural limit of visual acuity, and this completes the chapter of visual acuity. Okay, the next in optics point of view, this completes the chapter of visual acuity. But coming classes we will be seeing about how we can convert from one format to another format. So lecture will be about how you can convert the visual acuity of one format to another format, right? So till now, if you feel this lecture is informative and useful to you, please do like, share and subscribe this lecture. Thank you.